and innovative food technologies. He has previously served as faculty at Lovely Professional University, Punjab, and as guest faculty at the Institute of Chemical Technology, Bhubaneswar, along with valuable industry experience as a food technologist in the Quality Assurance Department at Milulol Lawlak and Sons. Dr. Syed holds a PhD in food process engineering from NIT Roorkela and M.Tech in food engineering and technology from Langwal, Punjab, and B.Tech in food processing engineering from Karunya University, Coimbatore. A strong advocate of outcome based education aligned with NEP, his research focused on nanotechnology in food systems, advanced food packaging, and self extension. Today, he will be speaking on the topic sustainable and functional. Thank you.
Thank you. Thank you, Vimal sir. I now invite Dr. Irshaan Syed to take over the session and deliver the talk on future of food packaging, smart, sustainable, and functional. Over to you, sir.
Yeah. One second.
Irshaan sir?
Yes. I'm there. Just getting in.
Yes. Now, please share your screen and stuff.
I hope it's visible.
One minute.
Yes, sir, it's visible.
Yes. A great evening. Good evening, one and all. Especially I'm glad to be here at this moment. Special thanks to the organizers. It's really great that MV and IT has welcomed us in this level, and the kind of program, the inaugural session, kind of PDP, professional developer program that has been taken is a good, good startup. What you're going to have, as the theme goes, the food origin, pioneering nutrition, sustainability, and crossing trends. It's a good blend of three things. Not only nutrition, how much sustainable can we be, and what are the crossing trends that we are going to concentrate. It's a great thing. Special thanks to the patron, the mentor, the organizing committee, everyone out here who has been taking a dialogue over the last 2 weeks for organizing all these programs. We can see all the speakers who has come been denoted out here, or a combination of HACCP, all the guidelines what are there, myself the food packaging line, and fermentation, what gut, what food what we eat, how it is going to interact with our gut systems and all, the 3D food printing technologies, as well as the smart as well as digital food processing technologies. Sivaranjani, she is a good friend of mine. So all the combination of the speakers what you're going to gathered, or of different disciplines, different broad aspects what we have chosen, just like my friend has introduced, uh, I would like to just brush up. This is a great combination, more than the student blend, the faculty blend is there. One of the great things this evening is I saw the list that even one of the teachers of mine under whom I was being taught, Dr. Dayanand sir, Peter sir. It's glad to see him in the list to bless us out here. Just to say, I had my bachelor's degree from Karunya University. I'm the student of Dayanand Peter sir. It's a great, university wherein it was to way back in 2006, 2010, the second batch of food technology grads. I was one among them. Uh, as the majority of the chunk of this session is the students, I would like to address few things before I just jump in into the session and go it a theoretical way. I want to share some of the experiences which is required for a food technologist to build in. I share not from text but out of my own experiences through which I have been built, so that some of the students can walk in the similar path, because I have seen the either side of the academics, the industry side, the startup side, whatever you call. And what is the next 10 years for the food technologist, what the way path they should take, if at all they are going to stay in India, or if at all they are choosing abroad in similar lines. So having said that, after doing my bachelor's, as I said, in BTech in Carnea University, I was of a thought that I should not continue my studies in a theoretical way. I should have some industrial experience. That's where I landed up in a spice processing industry. Myself being from Guntur, the land of spices, chili being the the largest hub of India. Guntur is there. The Guntur chili, it is having the highest very good Scoville unit, what we call. I thought like I should denote myself for some time for the spice processing industries. So there was a export company in the suburb of Erode, Mitula Lalas and Sons. There, what I had is, I'm just sharing my experience so that what makes a complete food technologist or the right path of food technologist. You should get some key giveaways or the insights. The main thing what I say is 1 year of experience. Why I choose is, you can definitely go for and a top up of internships when you go for your food technologist. Nowadays I have been in interview panels of lot many these industry interviews, or my startup company itself. I take lot many students from various universities who come as interns, who have joined as some of the students are working as interns in my company industry. I have initially started up one company which was Raitu Agro Foods, which was called Raitu is a term in Telugu which means farmer agro foods, which was an MSME bound thing. I ran it for 3 years, and out of that experiences, I have started something called as NutriShuttle Private Limited. I have launched a private limited company with a battery of directors, a complete private limited ship company, wherein which is there in my Guntur. It's nearly 14 kilometers from Guntur, in a village. I have started it with funding as well as from the ministry. We get startup. We when we pitch deck for some of the things, we get funds in through that formats, 3 lakhs in different kinds of formats. In there is some schemes which I will be denoting in the just 5 to 10 minutes. Prime Minister, Pradhan Mantri Kisan Sampada Yojana is there, one of the flagship schemes of government. In the similar way, there is Prime Minister formalization of micro food processing enterprises. This is a scheme wherein you can get up to 10 lakhs, through which I am also benefited. 10 lakhs through the banking scheme and 10 lakhs through investments kind of thing, wherein you keep one of your shares down into the market line, and you can definitely develop a company. So why I'm sharing all this is, food technologists, some of the mistakes what they do is, after a 4 year degree program, have been in the bachelor's in Karunya, in masters in Central Government University Punjab, and there again I have worked as a teaching field in Lovely Professional University, and did my PhD from NIT Rourkela, Odisha. Why I am saying is not to boost up what I did, but I have been through various locations of India, wherein I try to understand people, the kind of processings they do. And the whole of a thing what I understood at large is, food technologies, they come up with something like somewhere, when they are doing the bachelor's program, they develop some kind of product, and they don't know how to market it, but they think that developing a product with just a nutrition point standpoint is the wholesome thing. And maybe it may be okay for a BTech degree curriculum, passage curriculum, but not for a standpoint of to withstanding a job. Why I say is, the market now is diverse. For every 10 years, the dynamics of market do change. When we were childs, only there were biscuits something like Marigold, only Parle G. But now when you see Bourbon, lot many cream biscuits, there is a huge battery of biscuits what is into the market. They are not just because of the taste flavor, but also in the standpoint of what customer needs, what consumer needs. There are lot many people who are diabetic, India has become a diabetic capital. So for diabetic biscuits, what can you do? What are the fiber bound biscuits? Or what are, a lot many people are obese. What are the various kinds of milk based products which you can make for milk, obese people? There are a lot many people who are carcinogenic. So you get the target audience, modulate, regulate the food, and make various kinds of solutions to the problems which are there in the market. So just don't do any kind of projects in your BTech curriculum or in your master's curriculum or PhD curriculum just for a thesis sake. What I understood is even the government, the lot many schemes which government gives for the faculty members is not just out of switch. They give it for the themes. What is the now the current theme which is going, if I have to call, alternative proteins, food packaging systems, next gen foods, AI, integration of AI with the food, novel food processing sector. So government has allocations for these kind of areas. So if we write projects, if we do projects in that theme area only, we can do get. So in a nutshell, what I would like to crack is, in your bachelor's program, definitely go for, whenever you're studying a subject, definitely, if at all you're studying something like a bakery bound subject, confectionery bound subject, as a top up knowledge, definitely go and visit an industry and have your hands on practice on what is happening. What industry needs is to the point how much you are able to grasp into the system and come and deliver. It's not that you take some once 1 year or 2 years to learn and then understand the real industrial scenario. Then what is this 4 year BTech program for? So our BTech curriculums definitely are ramped everywhere, but it's the initiation from the student side to understand the industry side of the coin. What industry need, what kind of products, what we are making. The second side is how we are able to pitch it for it. When you are making one problem bound situation is there in the market, when you are trying to make one solution for it, and how will you pitch for it, how will you get funds for it, how many investors are going to be there. This is where there is their necessity for various kinds of all the stream of food technology, let it be food safety, food processing, food engineering sector, all of them integrated to work at modern engineering problems. How can we solve them? So problem bound solutions is the only theme what I would suggest to the budding food technologists out here, what you can work upon. In the second line, I have been the just to say, to stay connected with all of you, I'm saying, I am the Association of Food Scientists Technologists Guntur chapter president, wherein we are working in par with the industries in the Guntur Vijayawada circle, as well as Kakinada. Everywhere we are having this CFTRI bound AFSTI, Association of Food Scientists Technologists, wherein we have the stakeholders of every charge: the academicians, the students, the government bodies, FSSAI, the main ingredient, as well as the industries, the budding startups, as well as the investors. So we are trying to bring everyone at one nutshell, so that the students, when they come, we can guide them for internships or for the jobs, or the industries when they are saying that we are having not many problems in in their institution, we can route them back to what we call to the students, so that they can choose them as the student projects, work upon it, try to deliver a solution. When you deliver a solution, these solutions are mapped back to the industry so that you can readily be absorbed. So I hope the whole point agenda of me speaking for this 5 to 10 minutes is to think in some line wherein all students through this professional development is not about hearing some lecture. It's to understand that you take a domain. Just like after doing MBBS, every doctor definitely go for an eye specialist or a cardio specialist, gynecologist. They take a specialization. In the similar pattern, after your 4 years degree, the last part of the 6 months, take some theme line. Just don't take it for the internship just for granted. Any kind of industry is okay, chalta hai behavior. What I seriously denote you is, if you are interested in baking all of 3.5 years, just go into baking line. Do a very good project related to it in a baking line. Have a top up of master's knowledge in baking science, maybe in abroad masters, and then try to have your baking industry of your own. The real monetary benefit of a food technologist is not working maybe in a part to gain a knowledge for a 1 year or a 2 year in an industry is okay, but not as a whole. Because a lot many students complain that the startup salaries, the initial salaries after bachelor's is low, and definitely it's low. But when through experience, the kind of exposure what you have, the kind of experience what you have, the kind of maturity you show in the subject, there are a lot many pitfalls, limitations in food industries, Mondelez, lot many places, sudden, there is a downfall of this what you call when a line is running and there is a sudden program. As a food technocrat, how will you resolve it? That kind of maturity is what you need to have. So what I say is, get a 2 to 3 years experience of internship or any kind of experience, and then try to have a startup of your own, wherein you can get lot much of money by yourself. Start with and some MSME from bound thing. Definitely when you are in a stage wherein you can go for an industry scale, look out for that. That is the thing what I have been doing for the last 15 years after completion of a bachelor's program, step by step. So these are kind of sharings. Definitely you can log in into my website as well. The various kinds of products which my industry has been making, my research has been the domain is, was just I say just like meat chips, prawn chips, shrimp chips, meat crackers. What are these? What are this? Just to say, let me show you. Let me take you back to 1 second. The website of ours, wherein I can have a little bit more explanation on that. Yeah. You can definitely connect to me through the LinkedIn portal. I will be taking you in the next 40 minutes to the protein based thing, to the packaging based thing, the packaging kind of research, what I have done at NIT Rourkela, so that the research component in you should develop. It's the for a food technologies, it should be two things what I have learned from my experience. One is the research component, understanding the industry bound things, how industry perform, what are the regulations, what is the updates that FSSAI is giving. Previously when I was bachelor's, then it was a recent 2006 launch baby FSSAI. Before there were lot many laws, people doesn't know whom to contact, where to go. But now everything they are trying to formalize. Every year there are lot many updates that are coming with FSSAI. Try to get the updates of FSSAI. And coming back, Nutritional Private Limited, the main theme line when we have started it is, we have seen that the market is dominated with a lot many kind of these chips, what you call as potato chips. Wherever you go, you wine and dine, you go to various places. The only thing that is saturated in the market is potato based chips in our Indian scenario, Asian scenario. So what we thought is one problem. So always understand the problem statement. Just like a startup comes with a problem statement. Otherwise, it's a business next door. Why I call is, if you drive a bus, it's just a business. And there was a problem statement like from a recognized location to another recognized location. Let it be just say from Chennai to your one phase to another phase of Chennai. If normal buses fly, but from an unrecognized location, from your home to your friend's home, buses don't fly. So there come the different application of knowledge, the problem statement, how this Rapido, how this Uber has changed in. They have pitched deck that there is a problem statement. People are not able to going from one place to another place. Let me connect the dots through Uber, through Rapido. And there came a startup which has bud into a multi-crore unicorn business. In the similar style, in food business, there are a lot many avenues. Try to see what is the gap wherein you can work on your research practice, work in research in such a way that you can pitch deck for it, get investors for that, and start your own industry. That's a nutshell kind of thing what I can say. So just like I was saying, potato chips is at large. What we try to make is meat chips. Potato chips, they are definitely deep fried. They're having for our cardio health, they are not good. They're having a much bit of oils and all. So, and on the second note, they're not a good note on proteins. To solve all of them, we had the blend of baking technology, baking science, and we didn't added any kind of what you call uh, different kinds of your oil into our products. What we made is different kinds of meat crackers without any kind of oil. We baked the technology, baking through baking technology, high protein based foods. We got a patent for that, and that's how we entered into market. And spice all your resins. We are working with millet bound laddus. In a initially we used to do with earn while you learn. Students used to do. We had workers being doing over the years. We have switched and we have completely went into automation. The sweets are made with the automated laddu making machines, and in the similar way, millet bound muffins, biscuits. So these are some of the products which we are doing, and we are trying to hit our circle markets. And this is some of the things what I thought to show at the initial stage. So the main theme is not that I am doing, but I want to, guide the students, whosoever. It's a beautiful platform that your organization has gathered, and the, kind of experience what we come up with from Karunya, from, Sant Longwal Engineering College, NIT. What we have been taught is go as an entrepreneur. Entrepreneurship is the future. That is a kind of professional development. What you need to see, what you need to aim. When you aim, GPS is fixed, right? Everything will go into, correct path. If you are just, not having a proper aim, you'll be just working for 5 years, 6 years, 7 years experience, and still, quoting why there is not an improvement. Academics is a good line, no doubt. Research is something what you need to pour in, and something what you need to invest your time. After some 4 years, 6 years of your bachelor's program is industries. Indian food market is at large, even export potential, having a very good export potential. So we thought like nutrition should be delivered through packaging systems. That's what I have done in my PhD program. Antimicrobial system bound packaging material we have made, which I will be trying to discuss down the line. Antimicrobial system, emulsions we had tried to make, which will be coated over different kinds of meat systems, which will enhance the shelf life of meat systems. So it's all about delivery systems. So nutrients should be delivered. So NutriShuttle, that's how the name. We are the launch pad of healthy lifestyle. That's what we try to have. I hope this will try to have some kind of roadmap into the budding engineers. So going into the subject, not taking much of time, the the future of food packaging. I'm trying to share the slides now. Just someone try to confirm whether it is shifted back to 1 second. Are the slides shared now back from the website module? Can someone confirm, please?
Yes.
Yeah. Thank you, HOD sir. So, the future of food packaging, smart, sustainable, functional. For the students bound, I would like to say, it's not about jumping into the future or what are the various things which the Western market has adopted. Let us try to understand, always try to understand the problem statement. That's what I would like to focus on. Just like I have been saying, for the startup, the problem statement is the basis. Let us try to understand and let it for 10 to 15 minutes. What is the problem that is wrong with this current system that we are adapted to new systems? What was the packaging in the history before our Jesus Christ came into BC time? People definitely used to store the food. The bread was made before 2000, 6000 BC, 10,000 BC. The bread, flattened bread. Lot many things are there from process. The kind of fermentation is there 4000 BC into roll. So food was there. How was it stored? Glass was there 2500 BC. Wood was there 500 BC. Paper 150 AD. Metal came into play 1800 AD. Polythene came into existence 1900. So when you see the various kind of battery line, 18th century Nicholas apatization, canning, the first cardboard, the recycling process, industrialization when it has happened in the 19th century, late 19th century. And then after having the food packaging, therein people understood that we need to have some regulation. So the EU norms came into force in 2000 series, 2009, 2000, 1996 bound that decade. So every decade there is a constant improvement. Intelligent packaging systems came into play, edible packaging systems came into play. This RFIDs, sensors, QRs, we will try to discuss on these smart packaging materials for the beginners. But before that, let us, as I said, let us try to understand the necessity of that. Why is there so much of a hue or a requirement for packaging systems to be developed? Can't we survive even without these packaging systems? So as we see here, one of the biggest thing, India, as we see, for various factors, we are the first. We say that we are first in rice production, first in milk, for first in pulses, second in wheat production, largest in sugarcane. If you see the metrics, it's 150 million metric tons. It's a very huge volume, 248 million metric tons. Pulses, if you see 28, we are the top in the world for production. These demographics is speaks a lot. For the food technologist, you need to read in between the lines. When we are producing this much, what is the processing? We say that food processing, we are the processing engineers, we process foods, we increase shelf life through how? Through packaging material, through the processing technology, what you're going to dive into. So understand the theme line, understand the basis. We are the top producers, but we are not the top processors. This is somewhere the gap where every food technologist can turn into entrepreneurs, where every food technologist can keep some research analysis being done. So as we move on, we head. So see, if you see, when we see we are the top producers, the second scenario is there, and it's quite contrary. It's opposite. We see that only the vegetables, we are just 2% processing. Wherein if you go to the US, if you go to the UK, if you go to the Gulf countries and all Muslim countries, they have a very good processing. They have canned foods, let it be canned pea, canned vegetables, everything. They have a processing at large. Even our goods which are wherever they are processed from lot many portals, they are going to the abroad, but not to the Indian circles. So dairy, we can see that the milkman in our childhood, milkman used to come to various portals, but now dairy packets are at large. So dairy figures are 35% of dairy meat products. We are you packing to the Gulf countries and all, poultry 6%. Just like we have my startup, we have concentrated on this poultry. It's very small processing, but what is the wastage is the point where we have seen fruits and vegetables 25%, 30%. The figures are very huge. It's $1 million business which is going for waste. Our problem statements are those marine foods, huge marine foods. They have a limited shelf life. If kept in ice bags in a transport all through the market, you need to take care of it. If not, the quality chain is broken. That's where we will be speaking how we can have the RFID tag to have the temperature abuse being identified in the next slides. So understand something like what are the problem statements. Understanding that in depth of problem statements is the genesis, is the start for solution, is the start for research. Students have a mentality like going to the guides and asking teachers, say me the project title. They are nowhere the giver of any project titles. You yourself understand what are the problem statement in the market, what are the current solutions, what are the untapped things. So definitely you can definitely come into the market with solutions to the problems. So always food technologists should think in that margin. So as of here, we can see 80% of meat is not processed, 65% of dairy. If you touch fruits and vegetables, 98%. What I am trying to say is poultry we have touched. We have tried to process poultry into baked meat, into your meat technology, into baked meat chips, various kinds of product. Even we have entered into marine market. A lot many sectors wherein rather than going to abroad, a lot many products we are trying to add value addition, wherein we can definitely earn a lot. The product which is going for waste, if you can see tomatoes, one day they are 1 rupee a kilo, another day just few weeks, if you see they hit 40 rupees, 60 rupees. If you see onions, they are equated to gold, 120 rupees a kilo sometimes, and then the very next day you can see a fall of 6 rupees a kilo, 5 rupees a kilo. Even the recent trend has done. So food technologist role is somewhere in between these medians, in between these two goals, wherein you can have your technology make onion powder. When I was working in industry, we used to make onion powder, heated onion powder, wherein even different kinds of these market, which in the Gulf countries, in Toronto and all, they go for this onion powder. In restaurant chains everywhere they are going for this. So there is a good market when the product cost is very low. Try to process it. Think yourself making an small startup companies wherein you can invest in them and process the good and give to the various buyer circles. So always one of the key things what you need to understand is join various kinds of circles where you meet people on a regular basis. Something like industry panel members, something like startups, something like policy makers, FSSAI people. Try to get an opinion from all. When you are in a herd of just student mentality, not trying to understand the need of others, you will try to you will not have a broad minded thinking in food technology. So just to sum up, if we need to understand what is a packaging problem, we understand that primary packaging. When these primary packagings are I will try to have a basis of this packaging and then shift into this in the last 20 minutes. What are the recent developments? Secondary packaging or the units which we keep into intact The primary packaging is something where the food itself is in contact with the packaging material. That's what we have go with the primary definition. When these units are kept into secondary unit together as a entity, and then the transit packaging or the tertiary packaging is something which transferred to the stakeholders and a transport margin. Previously in 1960s or 1800 centuries, what were the main theme? What the people's need change. If I had to quote it, before some 10 years, 2000, 2010, people used to wait for parcels for 1 week also. We order some mobile, 1 week is also okay. But now, we have something like Zepto, something like Blinkit, wherein 10 minutes is the only time. We want something very immediately. Let it be mobile, let it be food product. We are not going to wait for long. So that is where the need of the people, they are in dire need of things. Just like the ad goes, someone wants to attend a party, she forgets something like the jhumki and all, the bangles, she orders, in 10 minutes it comes, and they are ready for the party. So what it means, the needs of peoples are changing. They want at everything in a need. And if that need is tapped correctly, if you understand the problem statement correctly, your startup booms. They're in the birth of the Zepto, Blinkit and all. So everywhere these trends, startups were not there in the previous 20 years ago. They were only industrialization was there, 1950s, 1980s, 1990s. Now this is an era which will be written with golden plate, that a startup era, this 2020, 2015 or to 2035, but if tapped rightly. So previously, the main function, what packaging used to do is bring one food material from one place to another place. I still remember in my childhood, when I have to get some pulses, get some rice from the market or from the store, they used to pack it in newspaper. The main role was to contain that material from that portal to my home. It was nothing, newspaper. It was not communicating to me. It was not of some, metered size. But now what you see in your supermarket, Dawat rice, whatever kind of rice, they come in 1 kilo packets. That is serving size. They come in 5 kilo packet, convenience factor, what you call. They come with some protection. They are protected from the environment. So the need, is changing every decade. They come with some oxygen barrier properties. Your rice doesn't interact with the environment. They have preservation. A lot many food materials, they get preservatives added. They have information. They are speaking to the customer. They have labeling. So to this this 1980s to 2010 kind of era is where the normal packaging material, it was not only just like containment like in 19th century, but in 20th century, 21st century, it's all about preservation, protection, convenience at various 1 kg, 5 kg, presentation, the brands, the technical, just not about the technical things of containment, protection, preservation. The marketing came into role. Everyone is like, whatever you keep into the food product, it's more about how you promote, that matters. The new era, the new packaging systems, they are trying to promote branding through packaging material. They invest a lot in packaging. Even we are, when we are initiated, we went with polyethylene pouches, polypropylene pouches for our meat chips. And then we have ourselves moved into different kinds of glass containers and all, because we want our meat chips to have the flavors interacted. We saw that there is a loss of flavors with our meat chips and all. So the point what I'm saying is, the industries, what they have invested, they want with come up with launch with different kinds of what you call the needs of the industry are changing, the needs of the customers are changing. So the characteristics of ideal package, we most of us understand. It should be not let the moisture, it should not let the gases, vapors, all these basics are there. Gas permeability should not be there. Our product get oxidized when oxygen is there. Carbon dioxide, these gases should not contaminate our product. Protection against light, order, these are some of the basics. Our product should not collapse, isn't it? Mechanical product property should be there. All these, it should communicate. These are some of the basics of products. There in 19th centuries and all, we had paper board, glass kind of packaging, steel kind of packaging, plastics, various kind of packaging materials, where we came with as per the needs. Different food commodities had different kinds of your adaptation to what you call the packaging materials. For instance, to highlight what was the problems, what will be the problem if at all I go for something like pickles with plastic with glass. Both things are okay, but glass is better. Why? When you're going with oils, different kinds of lipid bound systems, the package material, what your polypropylene, polyvinyl chloride, they migrate. When they migrate, now as you can see in some of the slides, I will be speaking about plastics, the kind of carcinogens it is delivering, the kind of problems, what early PCOD problems, what people are going to facing in the last 3 to 4 decades. Cancer it at large. When our parents used to be there, there was no cancer. As we can find, India is a cancer diabetic capital. How? Plastics is one of the basic reasons. So it's okay to go with plastics for pickles, but it's better to go with glass. So the adaptation is changing. There are different kinds of things where we can go for, plastics is okay with your cool drinks for, adaptation to the carbon dioxide. But when you go for glass, it's much better. So people, even the customer education is at large, but they do come up with their own rejection parameters and all. So one of the basis of this 19th century was the Tetra Pak, the patented technology. Any technology, any invention, any research, what you do, if at all it's working well, one of the things what I have been learned is definitely go for a patent. What is this Tetra Pak? How it has changed the dynamics? When a milkman comes to your, as most of you are first year, second years, that's why I'm going from the bottom approach. Maybe we will last for another 25 minutes, but I will try to cover everything. What I would thinking is, the milkman, when they hit your turstle, the milk used to, if the milkman used to give the milk at your homes, it used to last for, hardly hours. We need to heat it, keep it for hours. When we get the same thing in a milk packet, the polyethylene packet kind of thing, LDP packet kind of thing, it will last for 2 days, 1.5 day. When you go for Tetra Pak, it's going for 3 months, 4 months. The milk is same. How is it is having one shelf life when it is given direct, another shelf life when it is coming in polyethylene LDP pouches, when how it is getting some 4 month shelf life when it is going for Tetra Pak. That is the simple definition of food processing. Food processing is how you can extend the shelf life through the packaging technology, what you're going to adapt through the adaptation of science, the chemistry, food chemistry, how your flavor interaction happens with the packaging component, how your packaging material is interacting with the food component. When you understand, when there is an integration of all these engineering bound things, food chemistry, food microbiology, are there any microbial components that are entering into the package, or there any food components that are interacting with the food packaging material? When you understand as a holistic approach all of this, there comes the maturity, the birth of a food technologist in you. As we can see in this order, microorganisms, how much they can transfer. As you can see here, this is the normal Tetra Pak, 7 layered, 6 layer Tetra Pak. Everything what we are going to keep it in your is having a function. Try to understand food technology just not by remembering, not by understanding, not by application, but by analyzing skills, not by your creation skill. Go for higher levels of skill sets. What industry looks at, in every industry interview panels, what we said, what we seek is only something what we call as the skill set, whether you are able to adapt to the industry scale, not by theoretical knowledge, by your application skills, your creation level, whether you can do some R&D skills when you're coming of an industry, is what industry thinks at. So understand everything with the basic concepts. Paper, what is the need of paper? It's just for the strength. Polyethylene and all for the printability, so that they don't transfer this aluminum foil. It's a good barrier property, it's having a barrier property for oxygen. It will not let oxygen to go through. That's why oxidation of milk or any kind of your beverage does not happen. Higher shelf life, which happens with your normal counterpart of polyethylene and all. They are good, oxygen do transfer over a long time. Oxygen travel properties are there. So you need to understand everywhere. The thing what I highlight is with what you call is here with a packaging system with a chemistry approach. In market we have flexible packaging, metal can, glass, everyone, this carbon dioxide, when you open pouch, the aluminum foil bound things are there. When you're coming with your cardboard kind of thing, when you're going with a glass, it's necessarily not there. So what is the chemistry behind that? What is the necessity? Try to understand the rational thinking, why everything. What is the costing factor? What industry looks at is costing factor when we go for LDP, when we go for glass, plastic jar, the same material inside is same. How will you manage? So go with that kind of approach whenever you go for interviews and thinking. So in a nutshell, when we are saying about packaging material, what is oxidation, oxidation, how it is going to happen. In normal, you might have drank lot many times this 10 rupees water bottle, PET bottles and all. It is clear notification is given, keep it in a dark place, keep it, keep away from something what we call as a, you know different kinds of what we call the notification goes from sunlight. Why is it so? The main reason is, as we understand, when temperatures are at large, these polyethylene terephthalate, they have BPA, bisphenol A. It's a kind of chemical that is used in printing and all. That is, while making these PET bottles and all, that definitely is a component in it as an additive, okay, as a polymer bound additive. So it migrates into the food material. So that is the same reason why, when these food chemicals which are there in polymer matrix in a plastic bottles, they migrate into the food material. We are consuming plastics daily at micron level, at nanometric level, and over a large period of time, they are the reason for cancer, they are the reason for early PCOD, a lot many gallbladder problems, huge problems, headache, or to the nervous breakdown. Everything is rooted back to that. So the main theme line is adapt to something like glass or different kinds of novel food packaging systems. What we can create polylactic acid for this PET bottle, the CFTRI, DFRL, DRDO, they have come up with a solution. They came up with, which I will be showing in the next slides, a polylactic acid bound thing. Plastic will not, deteriorate for 100 years, 200 years, 400 years, but a polylactic acid material do in a weeks of time. So we call everything as plastic. We need to understand what are the various scales of plastic. 1, 2, 3, 4, 5, 6, 7. Okay, plastics are of various scales in various symbols. They come with all of them we think are recyclable, which are good at recycling capacity, which are mediocre, and which should not be. One should try to understand PET bottles, water bottles, and everything, high density polyethylene materials, PVC, polyvinyl chloride, low density, your milk packets, lot many, lot many things which you see, biscuit packets and all, bread packets, they come up with polypropylene, lot many things, polystyrene. Whenever you go for these serving counters, parties and all, at snack meal, you can see this. But they are coming with a caution. They are not for free. All plastics are not hazardous. They are, try to understand that plastics, when you understand what is the problem with the current plastic materials, then only we can try to understand the need of the future, the need of shifting to various kind of packaging materials. That's why I'm trying to have some impact, a little bit of more emphasis on this. As you can see, among these 7, something which are at green, safest choice, HDPE, LDPE, and polypropylene. And something which comes with caution at higher temperatures, polyethylene. Just like I said, when you keep in sunlight, 40 degrees, 45 degrees, they give the bisphenol A, various kinds of the phthalates, the printing packaging materials into the food materials, which will migrate. That's why it is avoided. You should not have the 10 rupees bottle drinking lot many times. It's just use and throw. That's why you should use crush and use, use and crush and throw, and not use it multiple times. That's why they go for the steel adaptation materials. There is a logic, there is a science rational behind everything. Polystyrene, one of the most harmful material what the food technologists see. So among them, as we say, highly recyclable, not recyclable, and definitely not recyclable polystyrene and polyvinyl chloride. Why? Because they come up with different kinds of toxic emissions, toxic products, which are leading to all these health hazards, which we'll be trying to discuss. I hope you understood what are the various kinds of products what we are seeing into the market, which are mapped with different kinds of plastic. Plastic all is not one umbrella. They come at different phases. So we see that plastic is having polymers, monomers, different. For the plastic to have your a rotation, they add plasticizers. Otherwise, they depart, they break into pieces. For having a motility, we add plasticizers, solvents. We add lot many antioxidants, different kinds of additives, anti-fogging agents, for having a not having a hazel effect and all, colorants. All these somewhere maybe are good for your identity purpose, but definitely as a chemical standpoint, they are not going to be good for us. All these plasticizers, they are coming with different classes, printing inks. What is the potential health risk due to migration of this? Let us try to understand the packaging flavor interaction. There are two things. Our food products can be migrated whenever you are having beverages and all, they can be migrated into the packaging material. On the other hand, the packaging, the main core problem what we have seen, I have seen in my PhD during an NIT Rourkela, is there's a lot much of migration of these plastics into the food materials. One of the finest things is in market what we see is newspapers. We eat samosa, we eat lot many these snack food items with newspapers. This bisphenol A, lot many packaging materials, that is a huge interaction of, the oily foods. They are very good absorbers. They absorb the plastic or the printing inks into our food systems, and we eat, and finally we are adapted to cancer. We see that our parents doesn't have cancer, we don't smoke, how do we end up with cancer? Plastics is, I'm trying to have an important awareness. Plastics is one of the solid reasons what it is for. Always try to go as an industrial standpoint. Even if you're startup, go for migrate for something what we call is, so there is a large much only 1% 2% of companies are working with what I see as a standpoint into plastic bound startups. There is a huge room for you to work. We are still going, hugely adapted to plastic. 60-70% of thing is with plastics, the current packaging materials. 30% to 50, 15 to 20% is with glass, and the rest with steel. Basing on the cost factor is there. So we should change. We should go for novel practices, something like bioplastics, something what we call as paper based things, something we go for. How we can go for adaptation of whether the packaging material is made from sustainable packaging material, from various carbohydrates, proteins, from food waste, turning food waste into wealth. How can you do that? We will try to speak on that as well. So try to come up with food contact material which is completely safe in nature. Otherwise the plastic kind of things, it is going to have huge concentration of, as I said, polyvinyl chloride, polystyrene. They come up with a lot much of toxicants, phthalates, and lot many things huge, whose concentration is at higher concentration. They will migrate into our food when the temperature is high. When we are serving hot foods, they definitely do migrate. And what happens is various battery of problems what we are facing in industries, in health concerns. Flavor scalping is some of the factor. The flavor of the food gets transferred to absorption is a surface phenomena, absorption is a whole mass phenomena, as we understand. The citrus bound, this you might have seen in if you keep a plastic bottle, water bottle, or any juice bottle in a car dashboard which is exposed to sunlight, and after a lot much of time when it is exposed to sunlight, when you try to drink it, what happens is you feel the plastic flavor even in water and all. Why it is so? Definitely it's something, the plastic migration of LDP or HDP into your food systems. Some of the research studies which of limonene, lot many things have been proven that LDP, HDP, they do transfer into food material. Flavor scalping happens. So the permeation of gases is one factor. Lot many scientists at NIT Rourkela, in NIFTIMS, in Karunya, whatever battery of institution, what they are working upon is they are trying to mimic the plastic with new kind of packaging materials which were made from seed material, which are made from different kinds of what you call peel based material, which are going to have carbohydrate, biomaterials, a combination of carbohydrates, proteins, and fats, so that they mimic something which are there with your 7 classes of plastic, and they deliver the same durability of what they can do. So that is the future of packaging. If we can concentrate more into startups and more into these kind of systems having the same, we need to understand here is what are, as a food technologist, go in depth every factor. What is the permeation factor of plastic? What is the permeation factor of glass? Means how are gases getting permeated? How much at what rate? How at one square meter per 1 hour per 1 day, at what temperature? How much of oxygen is transferred through a glass compared to a LDPE, compared to HDPE, compared to your polystyrene. So get the matrix done. Now try to mimic the same with various kinds of potent materials of carbohydrates. From seed based materials you extract the carbohydrate which is for waste. From the peel based materials, from the fat, from various fats which are for waste, you can process them, get the oil based materials, try to accumulate back. antimicrobial based things and all, and try to mimic that same of plastics. If you can get success in these lines, the future is ours. One of the things why we are, the current problem with the plastics is IIT has researchers, the PhD scholars of the last 5 years, they have proven it. It's nearly some 25,000 microplastics that are, whenever you're having this plastic cup, paper cups, you call it as paper cup, but there is a thin lining of plastic inside it, which for every 15 minutes when you are drinking hot tea, 25,000 microplastics are going into your tea or hot milk. So that's why even the it's said, go for adaptation to glass rather than plastic. So we food technologists should be the front runner, try to get awareness to the budding engineers as well as to the layman people about the impact of this. So as we need to, as I say, we need to understand the core problem of why we are avoiding this, the current plastics, the current packaging. Why is the need for the front runner is this phthalates, bisphenol A, hormonal imbalance. As you can see, lot many the deliveries which are happening, which are miscarriages which are going to happen, infertility problems which are at large. Everything is quoted back with references to this styrene, this mineral oil, hydrocarbons, everything which are heavy metals. All these are a basis of your normal packaging materials. So having understood the packaging, why there is a shift, all the researchers from the last 20 years, they are working on this. You can also serve as go for a research problem basing on this. The novelty of this is the choosing the largely available material, easily available material. You need to work upon the processing methods, how finer you can create, how faster you can create. And the main problems with the biodegradable material is the durability, is the strength. If the strength problem is resolved by the food technologist, if you can work upon it, that, and that can be a multi-million dollar industry where lot many investors are looking for. So edible packaging material is one of the recent insights wherein these plastics which deteriorate, which will not deteriorate for a larger time, can be replaced by plastics, non biodegradable plastics or edible packaging material which can be easily deteriorated. Edible film, edible coating, some of the research which I have done, which I will try to share in a nutshell, wherein I have worked upon various kinds of and what you call emulsion based systems. For a moment I will be trying to switch to the research part wherein an one second, I'm sorry for the pause. Share. Yeah, I hope you are able to see the screen of oil in water emulsions of geraniol and carvacrol. Can someone confirm it?
No, no, Irshaan.
uh,
In edible packaging only.
okay, share. I hope this share now. Is it visible now? Science Direct, the research article, what I'm trying to share in?
No.
Okay. Uh, is it now visible, sir?
No, ma. No.
I'm sorry. Just a second.
It says the screen sharing has been paused.
Okay, okay. Screen sharing is paused. Resume. Now,
Yes, sir. Yes, sir.
Yeah.
We can.
yeah, thank you. Thank you for the confirmation. I will be taking just 10 to 15 minutes more. I will try to sum up, but I want to, initiate in, that research iota in you. So having said the problem statement, the main thesis, emphasis the student should be not asking guide like what can we work upon. A guide should not write. You yourself understand why I was, trying to say the problem statement deeply is try to understand the market with a core what is the problem statement? How we can resolve is through research. When research is successful, try to patent it and try to have a startup of your own. The theme 3 point what I have followed. Okay, as you can see this, this is one of the project what I have done in my PhD program at NIT Rourkela. Emulsion, as we understand, oil in water based emulsion system. Geraniol, carvacrol, these are some antimicrobial agents which are taken from different kinds of spices, plant bases. Okay, so why we take is we understand that spices are very good at potent at antimicrobial compounds. So I have understood that spices are good at my antimicrobial compounds. Many plant-based things are good at antimicrobial compounds. I try to extract them, and when we apply them directly upon food systems, they have a limited shelf life. What I mean is, just like essential oil, essence. Why do we get an essence? Just like a scent is have when you have an scent over you and you go into a room, you get the essence. That is the particles there. There is a gradient from one higher concentration to lower concentration in an area. In the similar pattern, even these oil components, essential oil components, they depart. There is a surface gradient, and after some time, all of the antimicrobial components are gone if at all they are applied directly. So what we need to have is over a time duration, over a larger time duration, they should be released over a control manner. So what we can do for that, to eject them at a control manner, a delivery system is given. What is a delivery system? An emulsion. Emulsion takes care that it is not any kind of antimicrobial component is not going into the air or onto the food system over a brief period of time, but it takes a longer matrix. It takes a what you call a longer matrix of time for us to 1 second. Let me show the images of this research so that it can understand better. Sorry for the interruption. So what we try to hear is the problem statement is, as we can see, antimicrobial compounds are definitely there. Lot many components are there. They are applied upon different kinds of food systems. But what happens? What happens is when they are applied, they are having a limited shelf life. So what we have done is through emulsion engineering, we have tried to do sonication, ultrasonication to various kinds of formulation. Wherein this, I hope you're able to see my PDF wherein the ultrasonication and everything is shown. Emulsion based coating system versus a non-emulsion based coating system. We have tried to uh, integrate both the technologies. Are you able to see a model system and reference system image? I'm sorry. Are you
Yes,
able to
sir.
see?
Yes,
Yeah,
sir.
yeah. Thank you for the confirmation. So the main problem is meat systems. The market problem, what we have seen is in the butcher shops, in the market, meat cutting shops and all. They, in the Indian scenarios, we're a tropical country. We are okay with E. coli, different kinds of bacillus cereus and all. But when you see the Western scenario, the case is not so. Wherever you go, there is a contamination and there is an outbreak. Salmonella, all these these E. coli, their contamination at large, and they fall sick very easily. So what can be a solution for them? So whenever they get these meat products, there should be some ready-made system that they get their meat, they dip it into some solution bound thing which will make sure that it is free from any kind of bacteria. In market, what is the problem? Our these meat butchers, when they cut it and they again keep it in the soil is full of bacillus cereus, salmonella and all, and again they cut it, they get contaminated. So the main problem statement you need to understand in every food is this food safety. So how can you solve your food safety problem? Through integration of your food science knowledge, food engineering knowledge, food science, food microbiology knowledge. Is application is, we definitely need to have an antimicrobial compound. Antimicrobial compound, we cannot go for something called as any kind of artificial antimicrobial compounds. You should go for some natural is your first priority. Definitely we went for that. Antimicrobial components which are geraniol, carvacrol, different kinds of antimicrobial components which are from your natural sources. Second is longevity. It should have a longer period. That's where the food engineering courses you are studying, as I was saying in the very start, Peter sir used to take us something like engineering PEC classes, process engineering calculations. The real application of that I have understood when I was doing these projects and all. So try to study not every subject, like it might be feeling like tricky, might be some numerical for you, but there is definitely a application of it. It is going to solve some future problem of yours in when you are applying it. So that process engineering calculation, why I have applied is emulsion engineering. So the oils at initial concentration, what is the initial concentration over time? Normally it used to deplete in one day, 24 hours, but when you encapsulate in a delivery system, that is an emulsion engineering approach. In emulsion there is a low release, control release, so that if at all bacteria is there, it will go and kill. So it will go and kill. So over 7 days to 15 days shelf life it can increase if you adapt for emulsion engineering aspect, food microbiology aspect, food science integration you can have in your projects. So we had this goat meat coated with your what you call different kinds of emulsion which is having antimicrobial compounds, and goat meat not coated with your emulsion. We have seen the shelf life. We try to have the antimicrobial effect, how much antimicrobial effect it is going to have, what is the particle size of emulsion. So these are the various factors you should develop in, understand more of the core science. What is the particle size? The problem with the particle size is the more will the particle size they club in, and the emulsion droplet becomes larger and it loses its efficacy. So the nanoparticle size is what can be the solution therein. Where, so what I am saying, trying to say is nanomaterials will have larger shelf life. Nanoparticle encapsulation will have larger shelf life through my research, what I have understood. So we go for SEM, TEM analysis, transmission electron microscopy, just to understand whether our particle size is good or not. Over time, over 30 days, 40 days, 120 days, what is the particle size, how it is increasing. So when you find this kind of solution, you can market this over a patent, and you can definitely make a solution for an industry. Industries are ready to buy this. So all the theme area, what you should do is just get one core subject granted: baking, food packaging, food microbiology. Go into depth how you are, whatever you are trying to see over here is various kind of bacteria, how bacillus cereus gram positive is going to react, how gram negative is going to react when kept in a without any headspace. This is without headspace and this is with headspace. Why I am saying without headspace and with headspace is, let me come back here. When headspace is there in your packaging material, there is much room for the antimicrobial compounds to go. But when there is no headspace, with a limited headspace, antimicrobial components will be concentrated. That is validated, verified with research. So that's how, as a food technologist, you need to peep in. So what happens is, what you are seeing here is inhibition zones, the antimicrobial inhibition zones. When they are at large, that means that larger growth of bacteria is there. When the circle 2 is, which is smaller, it is in what you call your no headspace system. So we have done research for emulsion based system, non emulsion based system, headspace system, non headspace system. So in these kind of dynamics, what I call, you can definitely look out for research. In the next 5 minutes I will be trying to close in with some of the other kind of one second, let me go back to the slides. Some other kind of novel practices what we are trying to adapt. One is biomaterials, one is something like antimicrobial system, one is how can you incorporate this antimicrobial nanometric scale. When you go into nanoscale, I have said there is an increase expansion of shelf life and all, how it is going to happen. And then how you are going to have this active packaging. Let us try to understand that.
Sir,
Just
your
5 minutes.
screen is not visible.
One second, I'm going back. I'm just trying to shift. Is it visible now?
Yeah,
I hope,
yes, sir.
yeah,
Yes, yeah,
yeah,
yeah.
yeah. So, one of the main things what I was trying in a nutshell in next 10 minutes, just hold on. So ideal is edible packaging system is definitely good. How it is edible? The main problem we have seen with the packaging system with the plastics is all plastics, 7 layered plastics. So try to make some edible packaging systems from a combination of polysaccharides, proteins, which are from your natural components, carrageenan, chitosan, pectin, carbohydrate, protein from different kinds of protein, lipids. Definitely now what the food technologist role is how you can mimic the properties of the plastics. With this is the main problem. Food technologists are trying to play a role in it, but they are not industry ready projects which are very much adaptable. There are lot many food products which are still not developed with which are replaced by plastics. So a room is open. If you can tap the gap with your technology, definitely all your food technology statements, what I'm trying to emphasize is problem statement. Students, all of you think what is the problem statement? Now the problem statements are lot many food products are there for which there is no alternative of plastics. Identify them first. How you can make a difference through your food technology knowledge, through food microbiology, food engineering, process engineering calculation, emulsion engineering, edible film, how to make a non-toxic, natural, non-allergic. All these are the problems with the plastics. So through your edible packaging system, just like what research I have done, try to show, understand the problem statement with plastics 400 years. 400 years is the problem statement. This is how you pitch deck. In pitch deck, the investors ask like, what is the problem? Health hazard, the environmental hazard is the key problem. Okay, how are you going to solve? I am going to solve it through edible packaging system because they are biodegradable. Second, they are not going to harmful. Okay, what about the durability? What about the strength? This is where everyone is failing. Industry are okay now with two problems. They have replaced the 400 to 1 month, that is biodegradable. They have replaced that problem with your edible packaging systems. But what about something called as antimicrobials? Shelf life also they have gained, but something like the strength of the packaging materials and all the oxygen barrier properties, they are not that much successful. Let me try to show PLA based things. Lot many industries have come in, plant based, protein based, your lipid based, a combination of these three, or have already I will try to share these slides with you so that through the organizers so that you can have. So these are some of the industries in the in the western scale wherein they came up with biodegradable packaging materials. What I'm trying to say is the research angle. Now the research is made into industry, starch based, polylactic acid, plantic trace. No, lot many of these food materials, they are made with what? Not with plastic, not with LDPE. The Westerns have adapted to potato based starch, maize based starch, which is blended with other biodegradable esters. So that's why they food chemistry teachers always teaches you, try to understand what is ester bond, different things. Why? Not for free, but for you to make you understand that it is going to have an application for a larger scale. So if this kind of material is there, we can definitely, government, what is government saying? No for plastics. So when you come up as a food industry, food technologist, that a packaging expert, you can come as an entrepreneur. Industries are ready to, these governments, just like the schemes, what I was trying to say at the very start. Why I'm saying there is no scope for food technologists just to think like I will be working. We are not some computer based job that we go at 9 o'clock, come at 10 o'clock. The saturated jobs. Always think you work for 3 to 4 years in that line, but think of more of becoming an entrepreneur of 4 years of your expenditure, in a food industry. Gain the essence, get the maturity, mental maturity, physical maturity, technical maturity, financial maturity. These things maybe are looking like terms for you, but it takes some time for you to mature. But what are industries doing? How is the Western world doing? All industries are adapted, already doing, they have avoided plastic. They are coming into bioplastics, polylactic acid. This is one of the very good invention. Let me show you. This is not plastic. This is not PET bottle. This is one of the posts which I have done in my LinkedIn. All of you, as we are coming to the last phase, do connect it through my LinkedIn, wherein I will be sharing this kind of information, any kind of startup informations, so that we can I can guide you ahead after, even after this kind of podium. So Mysore, DFRL, DRDO, our defense organization, they have made with PLA, polylactic acid, and they have they are trying to make it in a commercial scale now, so that the PET bottles problem is solved. No more 100 years, 200 years bioplastic. Now, even the main thing what you need to look at is they are successful in the main parameter. What? The plastics were, bio-based plastic, starch-based plastic, polylactic-based plastic, bioplastic made materials were not competent enough in the strength. Now they have made it, our scientists, through even their technology of polylactic acid, that uh, these portable bottles can be, PET bottles can be replaced with polylactic. It's a huge breakthrough. In the investors can, multi-million scale business is there, huge scale. So in the similar lines, there are for oil, there is no replacement. Lot many problem statements are there. Now, for you researchers, it up to you how you can do this smart packaging, how you can do intelligent packaging. You know what this smart and intelligent packaging are. I will try to cover in 5 minutes. It's simple thing. What is the problem statement of active pack? Normal packaging. Now, normal packaging is just communication. Containment is what we have understood in last 50 years. But now the packaging is trying to speak with you. If at all some off flavors are produced inside the packaging material, your packaging material will be competent enough, it is active enough. If the main problem of some of the food is oxidation, you might have studied in food chemistry, oxygen is present. If oxygen is present, it will react with your lipids, and then your food materials, what happens is it gets oxidized. So oxygen should be removed. Who is removing oxygen for you? This packaging material is removing for you. This packaging material is absorbing the oxygen for you. This packaging material is emitting the oxygen or carbon dioxide for you. So there are various scales. So the packaging is changing material. The concept of packaging material is not containment, it is beyond containment. Plastics to bioplastics, packaging material which is speaking to the customer, packaging material which it itself is removing the oxygen scavenging, human scavenger they call, human eaters, just like that. Oxygen scavenging, oxygen removal, carbon dioxide. If carbon dioxide is problem, carbon dioxide can be removed. If water is the problem, water can be removed, water vapor can be removed. In shoes you might have seen something like silica based things which are kept in your shoes. Why are they keeping? So that there should not be any moisture formation on shoes. The shoes doesn't get where and all. So the silica, it will, the simple concept is silica will absorb the moisture. The same concept, active. So in the packaging system they are trying to have this active packaging system. Why they are calling active? Because your packaging material is trying to remove some of the gases from the packaging material, or trying to emit some of the gases into the packaging material depending upon the food commodity to enhance the shelf life. Simple concept. Oxygen scavenging, if at all high levels of oxygen is there in your food which is bad for your food product, lot many industries are already into the market, just like meat products. If at all oxygen is there, oxygen scavengers are there. They are made with different kinds of concepts which are detailedly given. You try to maybe time is not there to speak much more on that, but through research articles and all, understand the science, a rationale behind it. What is the chemistry, what is the iron powder, what is the different kinds of in silica powder, what is silica gel, how does it interact, how does it absorb white water. So that's why they are keeping in shoes, that's why they are keeping in lot many food products, wherein it is given clearly that it should not be eaten, but it is kept to remove the moisture, so that the water activity will not be disturbed. The food will not have excess amount of moisture. So ethylene scavenger foods, what happen, that ripen fast. So in order through that the food should not ripen, they're having KMNO4, the principal ingredient through which the KMNO4 will act as an ethylene absorber, carbon dioxide absorber. On the other hand, you have flavor absorber. So the problems of meat oxidation, moisture loss, all these can be solved. So on a nutshell, whatever problem statements what we are seeing can be solved through active packaging system, either through emitters or through carbon dioxide generators, ethanol emitters, antioxidants. Your foods have lot much of oxidation. So for that, what you need to have is antioxidants, and these antioxidants can be added into your packaging materials, which can definitely increase the shelf life. Intelligent packaging systems, to speak, one is active wherein the gases are monitored, one is intelligent packaging system. What is this intelligent packaging system? For example, you are buying one ice cream, you have not opened the ice cream box, but still you want to understand whether the ice cream inside is collapsed or not. How can you do? It can be done through your intelligent packaging system. What I mean is, maybe your ice creams are produced at Delhi. They are, coming up to your Agra to be sold in a retail. So during that time, they are definitely brought at minus 18 degrees centigrade through the transit system. Somewhere around there can be failure. There can be a failure of the lorry temperature system, wherein from minus 18 it has come to 0 degree centigrade for 4 to 5 hours. Within this, what happens is the ice cream collapse. And again, when it comes to Agra, they try to keep in again back to minus 18. So they try to sell it in retail stores without opening. You people can consume it thinking that it is safe. But what happened is temperature abuse has happened. So how to identify that? Intelligent packaging is a solution for that. So what they try to do, the recent food technology said, they're trying to have the RFID. One of my students is working on this RFIDs concept, intelligent packaging system on paneer and all. So packaging domain. So what we have is we try to have a tag, RFIDs or different kinds of. We have enzymatic based or various kinds of sensor based, biosensor based. Whether the microorganisms are developed inside the food or not, our biosensor will confirm, and it will say to the customer, the packaging materials itself will speak that the food is infected with E. coli, so don't buy. So there is a color change in the food product. There is a small tag what we given. These tags are developed by the food technologies which we are trying to develop our lab. Gas sensors, indicators, barcodes. So this is the generation what we are trying to indicators. I will try to show some of the examples. So these meat based products and all, as you can see here, it is trying to communicate with the it is not only containment, it is trying to communicate with the customer that there is a change in the color. If there is a change in the color, whether it is oxidized or not. So over 0 day, 1 day, 2 day, after 14 days, if it is kept at 1 degree temperature, maybe it is not oxidized. But when it is temperature abuse happens, 25 degrees, definitely it is oxidized. So the color change, if it is thorough purple, definitely buy it. But there is a fade of color, don't buy it because oxidation has happened. So various kinds of indication, all these kind of checkpoint, trademark, lot many industries are already there into the market for various portfolios to confirm the pH based sensors, the whether it is infected with E. coli or not. If at all there is a dark green to bright yellow, dark green, definitely buy it. Bright yellow color, but definitely there is a pH drop. There is the product has gone through a pH abuse. So the definitely it is not going to be in acidic nature or in a basic nature what you are looking out for. Don't buy it. So even before buying itself, the packaging material is trying to communicate with you. What else? So this is a generation that food technologists are trying to work in. So make your projects oriented to this. Work on smart packaging system, active packaging system, biodegradable packaging system, or something like indicators, RFIDs, normal IDs, or the square matrix IDs, or your 3D IDs, or the old things. When you go for RFIDs, even a bulk orders 1,000 pieces can be identified at once because radio signaling can be done, radio frequency signaling can be done. As you can see here, oxygen free packaging, pink color will be there. So what is the chemistry behind it is what matters for technologies too. A dye will be there. So how you make a dye, how it interacts with the oxygen. If at all high surplus oxygen is there, it will be there in pink color. If oxygen is not there, how it turn into purple color. So that's where the whole of the freshness indicator, the food products, the fruits and vegetables, the meat products, ethylene absorbers, freshness, fresh check. Lot many companies are there which are trying to have an packaging materials adapted to various food products, meat products, fruit and vegetable products, to various kinds of products. As you can see, fresh check, we can definitely use it. Fresh check, we can definitely use it, but not here. So what they try to say is they have a sticker. Only this sticker is developed by a food technologist. What that sticker? What is that adhesive? What is the tag trying to say? It is saying that if inside color matches with this color, yellow color or pink color, inside the food is not much of ethylene is not there. It is not ripened. If it is completely ripened, it definitely changes in color. So don't buy. this kind of label is already given on the food packaging system. So if the food products is completely ripened and all, the freshness checking of a food product can be traced through your barcodes, through your single digit codes, barcodes, or the new technology what we are going is RFID systems. Or lot, as I said, all these kind of QR codes or different kinds of barcodes, these are single scanners. But when you go for RFIDs, the recent technologies, even 1,000 entities, 10,000 at large can be scanned at once. The temperature abuse and all. So temperature sensor can be clubbed with a RFID, and we can say, whether you go for your moisture or your pH or your the main parameter, what we call is your water activity. Water activity biosensor can be tagged to your RFID, and it can communicate the large scale information to food technologist. So in a nutshell, in the given time frame, might be I have taken some little larger time frame. Excuse me for that. But what I thought to speak upon is problem statement. Try to identify problems. Do some good research on that, and don't leave your research. Make your research into some experience. Try to work on some experience and try to launch on your own startups and companies, so that will be a future and not working under someone. Become entrepreneurs. For more information after this, definitely come hit the LinkedIn portal. I will try to share in the group. We can definitely, if you have any questions, we can speak upon. Thank you to the organizers and my friend Vimal, who has given this opportunity. Try to connect through your university organization, and as well as I'm happy to see my my guru Peter sir.
Thank you, sir.
Peter sir, as well as students, budding students, all for this opportunity. Thank you.
Thank you, Dr. Yes. Thank
If
you,
any,
Dr. Irshaan.
if anyone have I have crossed the timeline. If any one of you have any kind of queries, you can definitely interact with me at my LinkedIn. I will be sharing it, so we can have a longer this thing. Yeah, you can continue, ma'am.
Yes. We now open the session for questions. Participants may also post their questions in the chat box.
Definitely, thank you, most welcome. I really appreciate all your thanks.
Thank you.
Yeah.
Okay. I now request Ms. L. Meenakshi, Assistant Professor, Department of Food Technology, to propose vote of thanks.
Thank you, Nisha ma'am. So, as we come to the conclusion of day one, it's my privilege to propose the vote of thanks. First and foremost, I express my sincere gratitude to a distinguished speaker for the day, Dr. Irshaan Syed, for his highly insightful and enriching session on future of food packaging, smart, sustainable, and functional. His expert deliberations, practical perspectives, and forward-looking insights have greatly benefited all the participants. I thank all the participants for the enthusiastic presence and which truly made this session meaningful. With this, we conclude the day one of the program and look forward to your continued participation in the upcoming sessions. Thank you.
Thank you.
1 minute. Dr. Irshaan.
Yes, sir.
You have given an excellent presentation.
Thank you, sir. Thank you, sir.
Especially the startup, the problem statement for anything problem statement is
yes, sir.
great thing.
Thank you,
And
sir.
startup and how to become entrepreneur. Along with that, you have covered research also. So it's a blend of many ideas which will surely enrich our
Thank you, sir.
And for faculty
actually
also,
I like the the kind of integration, what the planning, what your organization has done. Try to mix every portal of people into one benchmark, so that the students can be benefited, the faculty can be benefited, the real professional essence can happen. So big thanks to the organizers for this kind of opportunity for meetup, sir.
Yeah, this credit goes to our coordinators. team of coordinators, Bhagyanisha ma'am, Bimal and Meenakshi ma'am.
Yes.
And on behalf of my friend Peter and myself, I thank you for your wonderful presentation. And on behalf of our college
Peter
also,
sir is my guru, sir. My guru. I'm always indebted to him.
Okay. Thanks a lot, Irshaan sir,
Ji sir,
for
ji
your
sir.
excellent presentation.
Thank you, sir. Nandri,
Sir,
sir.
good evening, sir. Good evening, sir. Hello?
Yes, sir,
yes,
you are
yes.
audible.
Sir, can I share today class PDF, sir?
Yeah. We
PDF,
will share it. We will share to the organizers.
Okay, sir. Thank you, sir.
Okay, dear. Thank you. Take care.
Yes, okay. Thank you,
Okay,
Irshaan sir.
okay,
Thank you,
okay.
HOD sir. Thank you all.